Hello, good afternoon all. Welcome to this first live session for Geotechnical Engineering 2, which is being offered by Professor Devendra Narayan Singh of IIT Bombay. We are the TAs for this course. My name is Fakra Rashid and I am a second year PhD research scholar. I work in the field of geothermal energy and how it can be extracted from oil wells that are exhausted. My main focus is on the heat and mass transfer processes that occur in the subsurface and how the porous media behaves when high temperature and pressure is there and the fluid is entered into it, which is having different properties. We'll first have a discussion of all the scholars which are here. They'll talk about themselves and their topics, and then in the meantime, whichever questions are being posed, those we will be discussing. I'll give the opportunity for other scholars to introduce themselves.
Good afternoon all. Myself, Runal Bukade. I work in the area of weatherization of dress sediments and landfill mine soil extractions. So here I am trying to see how bulk utilization of anthropogenic geomaterials could be their application in civil engineering purposes or infrastructure development purposes. So herein I am focusing on how organic matter will be behaving with the mineral phase of the soil.
Good afternoon, everyone. I am Singh Manohar. I am first year PhD scholar and I am working on risk associated with geological carbon storage. So mainly in my work, I am seeing what are the risks associated with it. Geological carbon sequestration like the fault activation, induced seismicity or dissolution of the carbonaceous rock. So mainly my focus is to cover, I'm going through the literature of the dissolution of the carbonaceous rock.
Good afternoon all. Myself Kamran Lai. I am a earlier research scholar under Prof. Singh. My topic of research is carbon capture and mineralization in industrial waste, which are the anthropogenic geomaterials. And right now I'm doing some experiments to understand the absorption capacity of these materials towards the carbon dioxide waste.
Good afternoon all. I'm Yogendra Narayanan. I completed 1 year of my PhD. So I'm working in the broader aspect of multi-phase geomechanics, which is a combination of soil or rock solids, water, and a gas. So how these phases, when existing simultaneously in a system, behave geomechanically. So in this context, I'm working in CO2 storage of deep saline aquifers. Thank you.
Hello everyone, I am Singh. I have completed 3 years of my PhD and I am working on utilization of waste rubber for sustainable development. Here basically I am trying to replace sands and gravels using rubber aggregates. Furthermore, I am also trying to make composites out of waste rubber and waste plastic from landfills. Here in my topic, all the basic concepts of geotechnical engineering, then chemical aspects, physical aspects, biological aspects, all are associated. So you can visit Prof's website and you can see there my mail ID or Prof's mail ID and you can update us. Thank you.
So good afternoon, I am DN Singh. I am the instructor for this course and I hope those of you who are following the lectures are enjoying this course. As I introduced in the introductory session, this course is the application of whatever you have studied in the course Geotechnical Engineering 1. And you must have realized from the introduction what my students have given here about their topics, that how the applications of the basic concepts can be utilized to make a good research work. Now, coming back to the course, you must have realized the application of the properties of the soils in terms of their shear strength and how material behaves once it gets sheared. All right. So, shearing is a process which also induces dynamic action in the material. Alright, this I think we have discussed quite a lot. So you must have realized that when some of them are talking about their topics, how the concepts of geotechnical engineering too, particularly stress strain, what Logan is talking about, that if you are doing sequestration of carbon dioxide, what type of deformations the material will undergo at what strain or deformation. So this part you will be studying later on when we'll be discussing about dilation, compression during shearing. Similarly, you must have realized from Singh's discussion that he is talking about the risk associated with the carbon dioxide capture. And one of the basic risks or the most important feature of this risk is, suppose you are injecting a gaseous phase in the saturated porous media, which happens to be the rock mass. And suppose there is a fault, geological fault. So CO2 is very corrosive in nature. All right, it's an acidic gas. If it gets diluted in water or the brine solution or the pore solution of the rocks, the chances are that it may eat up the sealing material of the faults. And if it happens, there will be an easy access of CO2 from beneath and it will go into the atmosphere. And this will cause a big hazard. There could be a possibility that CO2 may also become a part of the water table. So these are live examples of how shear strength theory has been or can be utilized for solving the problems which are becoming a major challenge for the sustenance of the humanity. All right. And as far as Singh was talking about his topic about utilization of rubber waste, this is a very interesting concept where whatever you are studying in geotechnical engineering too can be applied to do a very fundamental research. How? So far we have been talking about rigid porous medium or rigid grains of the soil. All right. Now suppose if I replace these rigid grains, which are mostly quartz or silica particles, if I replace these grains with a material which is more deformable, like rubber, plastic. Imagine plastic being converted into granules and these granules being used for some specific purpose. Okay, so if I want to load these granules made up of plastic or rubber, the first thing which we have to make sure is that they will not deform, or even if they are deforming, how much they are going to deform. So this is a fundamental difference between whatever you are studying in classical geomechanics, where the particles are absolutely rigid, the matrix which was created is rigid, no deformation is taking place because of the static loading. Except for the case when we are talking about compaction and consolidation, where the water was coming out in the form of excess pore pressure, the deformation took place. So from this point onwards, you are realizing that the basic concepts become more intriguing. I will not use the word complicated, but more intriguing. And they can be utilized in solving the problems which the society is facing. So his thesis is all about deformable porous media. So far what you are studying is rigid porous media. All right. Similarly, Kamran was talking about his topic where he is trying to mineralize through chemical action. He is trapping carbon dioxide in waste material. He is mineralizing it. Now the question would be, what has happened to the material? Whether it is getting interlocked, whether it is getting solidified, whether it is becoming more strengthful, how much, why, and so on. So what are the topics they have talked about is the recent development. Similarly, Manal was talking about, landfill mine material, whether this can be compacted. And if it can be compacted, what will be the strength with this material will be exhibiting. I hope you are realizing these are the very important topics on the day. Then you can superimpose on these type of concepts, how gas is going to migrate, how water is going to migrate, how shear strength is changing, all those things which we are discussing. Except for her case, Fakra's case, where she is talking about how to extract heat from the geothermal wells. But there also a lot of shear strength is involved, because when you are drilling the well, that time you should be knowing what is the strength of the material. Now it becomes not the shear strength. In her case, this would be when you are drilling a well, this has to be tensile strength or cutting strength of the material. Alright, so this part also I have discussed in the lecture, that from a simple triaxial condition, how I will be able to find out the tensile strength of the material. Alright, so if you extend this more Coulomb envelope, and wherever it dissects or intersects the x-axis, that much is going to be the tensile strength. So the whole idea of bringing this team over here is keep an eye on what's happening in the recent times, how these subjects are being evolving. But the most interesting thing is, unless your basics of the geotechnical engineering 2 and 1 are clear, you cannot approach these problems. This is what actually I wanted to emphasize. Anything which you think I have missed out, we can add it over there. Of course, please keep on asking questions. Otherwise, we'll keep on giving you the general information about what's happening in our laboratory, what my TAs are doing. So, good afternoon is fine. Penpuri, Inshaf, and Prakash Kumar. In case you have any question, please go ahead. Ask. Please want to add something? Anybody here?
So like this course, like follow a course of geotechnical engineering 1. So from there, like now you will be able to see the transition, like how to say setting up this topic. And I hope like you are attending the lectures and you will be having some doubts that I'm sure that you will be asking on the forum, but here also, like you can interact with us for your doubts. And like these are this subject is very important in perspective of civil engineering. So whenever like you will be in future, like whether you join some company, you will be doing job or you follow your research. In both of these cases, like you will be, these concepts will be required. Whether like in one form to solve the problem, and other form to understand like how what is happening and what can be the possible reason behind it. If some failure is happen or something is happening, then what are the basic reasons when issue is associated with it. So I think this will be a very important subject for which will be helpful for your whole career.
So you have raised a very interesting point. Like I'm sure those of you who are following the national news, you must have realized that because of the rains, a lot of damage has occurred in the northern part of the country, all over the world. But India is also very much affected, and you must have realized that excessive rain causes loss of shear strength of the soils. All right, and then erodibility. Soil erosion takes place because of excessive rains. And once the soil gets eroded, the chances of landslides triggering become much more. So at the end of the lecture, I will also be talking about the landslides, slope stability. And that is nothing but the application of shear strength theory. Right? So starting from these basic concepts, we have touched upon a very interesting point about the failures. So this is what the application part would be. It's something to add.
Initially, I as far as this course is concerned, initially the emphasis would be a continuation from the previous course on understanding the uh, it will be transitioning from basic understanding of the material to its engineering insights. So towards the end of geotechnical engineering too, we will be studying how these properties of the materials can be applied to the real life situations like lateral earth pressures, retaining walls, slope stability, the later subjects towards foundation engineering and so on. So shear strength plays an important role in soil mechanics to understand for engineering the structures. So it should it has a major emphasis when the whole subject of soil mechanics is concerned.
Or anybody else?
So, here, geotechnical engineering one course is all about understanding the material, and then this part is about the application of it. So as you all know, due to explosion of population growth, there is rapid industrialization. So there are a lot of issues that are coming up, and we geotechnical engineers have the basic responsibility of understanding these systems. Like in this course, you'll be learning about the soil structure interaction, soil water interaction, and how these concepts you can understand and then try to develop like if there are soil contaminated areas, or how you can remediate them, but how we can contain them, or the nuclear disposal facilities. These concepts, these basic concepts like the retaining walls, the issue of the abyss flow these days, where we have a lot of loss of shear strength in the soil strata. So all these concepts you will be using in applying after you graduate. But regarding this course, is a very important course as far as GATE is also concerned. There is like the maximum number of questions that are asked from the geotechnical engineering. And also after you graduate and in your interviews, you'll be facing a lot of concepts. And also this course is very important in a way that, for example, if you are building a structure, so all the loads actually they pass from like the slab to column, column to slab, beam, beam to column, and then ultimately the foundations. And the foundations transmit the loads to the soil. So the soil is very important part of, like it is the integral part of all the structures. So understanding the soil, like if you're regularly watching the lectures and asking doubts, I think that will really help.
So you must going through the lecture. Now you must have gone through up to the lecture number 14. Now you have covered the direct shear test. Now next week the lecture that the triaxial shear test will come, and so this up to the lecture of 20 lecture. This is the basic. After that, when you go through the further of this course, then you will encounter the slope stability, retaining a structure. So these all application, these all laboratory tests will come. So my suggestion is to focus this test carefully. This all concept you are going to use in the further course. Thank you.
All the points are covered, but what I would like to emphasize is side by side you should observe what is there in your vicinity and try to correlate the concept what is being taught in the course with the practical situation. So you will be more thorough with it and you will be more confident while dealing with the situation.
What he is saying is relate what you are studying and what's happening outside. You know, what nature is doing, the type of chaotic situation which is existing. How will you correlate these two? And once you have correlated, when the concepts are clear, how will you make mathematical models? How will you try to address the instability so that the whole thing can be stabilized?
So, most of the things have been covered. I just wanted to reply to one of the query that was asked that to have more practical applications and more practical examples in this course. So as the course is starting right now, it will be the introduction part, but you'll see that a lot of examples and a lot of situations have been discussed by professor in this course based on his vast experience. You will see that at every point there will be some of the examples that is based on a project, and then professor will be discussing about it, how a particular test will be performed at a particular site. So as you go through the course, you will be able to realize that it is a very different course from whatever geotechnical engineering you will be otherwise studying. You will be given first-hand experience of all the testing and where the particular testing has to be applied. So while similarly, while going through the assignments also, it is very much beneficial and very much useful that if you go through the geotech engineering one course first, so that you are very well versed with your basics. It happens that most of the students are not able to follow the assignments or questions because they are not knowing about the characterization or the classification of the material first, and then go for the solving of the assignment. That will be very helpful for every one of you if you want to score well and actually understand this course.
So any questions you have for us? So from our side, I think we have already communicated what you should be doing. In case you have any question, you want to discuss something, please feel free. Okay? Yeah, what is the question?
That one more practical knowledge.
So first, my suggestion is that you learn the basic concepts. Yes, please. In Puri, in Shaf, I have question. I try to send, but it's too long to write in UT. You try to write the question. Let us see what is the question. Chinuri Shiva Prasad. Hello, sir. Good evening. This is Shiva Prasad from Hyderabad. I for the plane strain condition is the stress perpendicular to the plane is ignored. Wrong. This is your answer. I for the plane strain condition is the stress perpendicular plane is ignored.
So wrong.
Is wrong means no, we are talking about two-dimensional situation right now, correct? We are not talking about the three-dimensional situation. Stress perpendicular to the plane cannot be ignored because stress is coming. Strains are going to be ignored because strains are tending to be zero. All right. The plane strain condition means it's a two-dimensional case. First of all, the confinement will always be there. If you take an embankment and if you cut it from here, what's going to happen? On this plane, the resistance is coming equal and opposite from the other part of the embankment. All right. So the stress perpendicular plane is not ignored. Strains are not developing. That is what the situation is. The same thing could be in a cylindrical system also, which is what is known as axisymmetric case. So there is a symmetry about the axis. Suppose if I take a cylinder, all right, and if I apply stress at this point, so stresses are changing in the R direction, Z direction. Okay, these are the two situations. So this is also a two-dimensional problem when we say axisymmetry. Yes, you want to write something in the YouTube, so please write, send your question. What's your question, Chinuri? I am not clear. Wrong means? Oh, you are asking a question. Okay, next question. Thank you. Then any other question? Or shall we close the session? Okay, I think we can close the session. Oh, just a minute. Aishwarya, how landfill plastic can be recovered, avoiding thermal treatment? What this has to do with the Geotechnical Engineering 2 course? First of all, you have to realize what is the meaning of the word recovered. It gives a lot of ideas to me. How landfill plastic can be recovered, avoiding thermal treatment. I don't know what is in your mind. Why do you want to recover the plastic from the landfills? Number one, this question, correct? Number two is, if your question is that how to utilize the landfill biomine plastic, avoiding thermal treatment, is it the question? I'm not clear. Thermal treatment could be incineration also. So ultimately, all this plastic is going to the industries for their boiler units in the form of RDF, residue derived fuel. So thermal treatment has to be given. Now, if you see some of our recent papers which we have written, there we are showing how landfill plastic can be utilized for making different types of composites. So follow the research paper then. In assignment number 1, question number,
Assignments cannot be discussed.
assignments cannot discuss because over.
One of what like we can write it down in the.
Okay, so I think this question is not valid, Chinuri. What is that you want to discuss in this context? I have sent question in doc file. Where is the doc file? To whom you have sent this? Can you please type over here? Cut and paste. Prakash Kumar. The ratio of the theoretical critical buckling load column with fixed end. You are talking about which course? Environmental Geotechnology 2, we have not discussed this, correct? Bharti is asking if there is any correction in assignment number 1. No, no correction required. Chinnuri Shiva Prasad, okay to what? Okay, fine. Assignment number 1. Any other question which you have? Yes, I think we have discussed quite a lot of things in the course. So my suggestion is please solve the problems to understand whatever is being discussed. And when you are solving problem, you should be sure about how to interpret the data. You must have realized that I am giving more emphasis on, even if I get a data point on a tau sigma plane, how do you interpret? That means there is an importance of the material for which a certain result has been obtained. So mathematically, it appears to be a straight line passing through 0, 0. But then if it is a silty material or silty sandy soil, then this concept is not correct. because by definition of silty sandy material, it should be exhibiting some cohesion if there is some moisture. Alright? If it is a dry powder form, then it's a different issue altogether. So please try to inculcate this when you are studying this course, that data point is mathematically derived, but it has to be interlinked with the material characteristics. So in this course, it's very important that try to understand the material. And for that, your concepts of geotechnical engineering 1 should be very clear. You remember the whole characterization which we have done, where we have shown what type of material this would be. So that knowledge will be very useful now. I want to ask concerning the relationship between the dry soil density test using the Proctor test and the shear strength of the soil. Okay, so what I know is the Proctor test is adding water little by little to get the optimal water content and get the maximum soil density so that the dry soil density increases. It's not like this, the way you are writing. When you are doing Proctor compaction test, you are trying to see how much the material can be compacted if I add water. That means I am replacing air from the voids. Correct? And then I am compacting and I am trying to see how much density can be achieved. Okay, so if I keep on replacing air from the voids by adding more and more water, the compactability increases. So gamma D increases. That means shear strength is going to increase up to a certain limit. And this is where the concept of pore pressures will also come in the picture, which I will be discussing later. At OMC, what will happen to the pore pressures? So when you are compacting the soil, you are removing air, the water gets filled up. That means what's happening to the pore pressures? Alright, so all these concepts will come. But in the concept of shear strength, soil shear strength equal to cohesion plus sigma minus pore pressure into tan phi. Yes, that's right. So tau is equal to C plus sigma prime tan phi. Okay. So what is the question here? It can be seen that the addition of the water reduces the effective shear strength. The way you are describing the water and this water are different. We are talking about shear strength reduction due to the effective stresses, due to the pore pressures. Now, when you are doing compaction, you are adding water, expelling air, making system more saturated. Fine. So these are two different concepts. When you talk about the pore pressures have to be in a saturated system. It can be in unsaturated soil also because of the application of external stresses. Remember Tarzani's theory. That concept has to be used. Don't mix up the two things. Here it can be seen that the addition of water reduces the effective shear strength. That is true, but the context is different. But why in the Proctor test and add water little by little instead it increases shear strength of the soil? I think I have clarified this. Shinori, okay, madam, thank you. I will contact you. All right, thanks. So you have raised an interesting question, but at the same time, be careful. Try to understand that one pore pressure develop. Pore pressures might develop in a saturated soil while you are compacting it or while you are doing consolidation. So the moment you apply delta sigma, the whole thing goes and gets reflected in the pore pressure development. And this incremental pore pressure will tend to zero, which is consolidation theory. Got it? So please make sure that you should not get confused. Compaction is replacement of air from the soil mass. All right? Yes, next. Okay, if there are no other questions, we can say goodbye. Thank you.